What are we trying to do when we install a PID in an espresso machine? Basically, we are trying to better control the heating element to deliver better temperature stability and more precise temperature for your espresso. To explain how we install a PID in a single boiler espresso machine, I'll use the Rancilio Silvia as an example, which is a very common machine in Europe and the US, but the concept applies to any single boiler machine. There are some differences in components and wiring, but with the rationale that I'm going to explain here, you will be able to install in any single boiler espresso machine. And I'm not covering the thermocoil and thermoblocks because these machines, they are more difficult to control the temperature. They are less precise even when you install a PID. Okay, and if you don't know, the thermocoil and thermoblocks are machines like the Breville, also commercialized in some countries as Solis or Sage, and also machines like the DeLonghi Dedica or Oster. Okay, so how is the Rancilio Silvia inside? It has a heating element, 3 thermostats, one for steaming, one for brewing, and the other one is an overheat protection thermostat. In some machines you will have a thermal fuse. It will not affect anything in this installation. It also has a lamp that shows if the machine is on or off and if it's ready or not to brew and steam. We have 4 switches, one for power, another for steam, hot water and brew. Some machines, they don't have a hot water switch. You will use the brew switch and you will open the valve and it will deliver the water through the steam wand. Another difference in the Rancilio Silvia is that it uses double switches, and some machines it's a single switch, which means that one of the phases is connected straight to the component that we want to control, and the other is controlled by the switches in the machine. Then we have the boiler and the pump that any machine has, with pump overload protection. This is native in the UCA pumps, and the UCA pump is the most common water pump used in espresso machines. Almost all of them use UCA. Different models, but it's the same pump. Then we have a solenoid valve that not all espresso machines have, basically to reduce the cost. And what it does, when it's on, it will make the water go to the group head, and when it's off, it will release the water and the pressure to the drip tray. Why it is important or beneficial to have a solenoid valve? When you stop brewing, you will still have some pressure and water in the line. If you immediately remove the portafilter from the group, you may get burned and you can make a mess in your kitchen. For me, this is the main benefit. Some others like the fact that you may get a drier pump when you remove the portafilter, and it may be easier to clean the portafilter when you knock your portafilter in the knock box. In general, almost everything comes out, and when you don't have a solenoid valve, sometimes it may be a bit wetter, and yeah, it may get a bit stuck. And finally, if you have some pressure and water in the line, and if you don't remove immediately the cup under the portafilter, it will drop a bit more coffee in your cup, and if you're aiming for a given amount of coffee, you will have a bit more. It will affect your ratio a bit. Some people get nervous about it, but to my view, it doesn't affect the quality of your beverage. Okay, and how is the machine wired? From the power cord, you will have a ground wire connected to the solenoid valve and to a metallic part of your machine. In the Rancilio Silvia, it is connected to the boiler, some others to the frame. Then you have a blue phase going to the power switch and the brown phase going also to the power switch. The blue phase goes to the brew switch, to the hot water steam switch, to the lamp, and to the heating element. It is connected to the overheat protection thermostat, that it's always closed, except if it achieves 165 Celsius degrees, then it opens to protect your machine. Otherwise, the energy is permanently delivered to this end of the heating element. Then we have a group of gray wires that connects the steam switch to the brew and steam thermostat. The red wires connect the brown phase to the brew thermostat, to the steam switch, to the hot water and brew switch, and straight to the pump. Note that it is delivered to one side of the steam switch and to the other side of the hot water and brew switch, which means that in the steam switch it is connected to the superior connector, and in the hot water and brew switch to the inferior connector. You also have a group of white wires that connects the black phases from the brew switch and the hot water switch to the solenoid valve and to the pump, and an orange wire that will connect the red phase from the brew switch to the solenoid valve. Finally, we have a yellow wire that connects the lamp and the steam thermostat to the heating element. And what is the rationale behind this installation? So when you have the power switch on and all the other switches off, you're expecting that the machine is getting hot and ready for you to brew. So this end is permanently fed by this black wire, but the other end should be fed by the red wires, right? So how the energy gets there? From the power switch, it goes to the brew thermostat, which is always closed, except if the temperature achieves 95 Celsius degree. After that, it goes to the steam thermostat, which is always closed, except if it achieves 125 Celsius degree. Then the energy flows to the lamp and to the overheat protection thermostat. When the temperature achieves 95 degrees, this brew thermostat will open, the heating element will stop heating, and the lamp will be off. Then you know when the lamp is off that the machine is ready to brew. Then you decide to brew and you press the brew switch. What happens now is the black wire will deliver energy to the pump and it will start working, right? At the same time, you're delivering the black phase and the red phase to the solenoid valve. It will close and send the water to the group head. When you stop brewing, the solenoid valve will open and release the water and pressure to the drip tray, and the pump will stop working. What if I decide to steam? Then when those switches are closed, only one will work, right? One of them is not used. So now the energy goes from this end to the steam thermostat, and when it achieves 125 Celsius degree, this switch will open and it will stop heating. Under 125 degrees, it will be kept closed and the heating element will work. What if I want to get some hot water from the steam wand? When I close this hot water switch, the black wire will be connected to the pump, and you will open the valve manually to get water from your steam wand, and you will not activate the solenoid valve because you want the water to go to the steam wand and not to the group. Oh, and I forgot to mention, what if you don't have a solenoid valve? It will not affect the PID installation, okay, because it's only meant to deliver water to the group head or to the steam wand. If your machine doesn't have, there's no connection to the PID. Okay, so now starting the installation, you will remove the brew thermostat, not necessarily physically, but you will disconnect. So basically, what you're gonna do is you will disconnect the two ends of the brew thermostat. Okay, I already told you that the thermostat will activate when there's a 10 degrees Celsius difference in temperature. So when we say that a PID allows you to have a better temperature stability, it's because it will work with 1 degree Celsius difference. And also it's going to be very precise. If you define a temperature for 90 or 95 degrees, you will have more or less 1 Celsius degree difference from your target instead of 10. Okay, so now to connect the PID, you will bring a black wire after the overheat protection thermostat to the number 2 or to the number 1, but I put in the number 2 of the PID, and after the overheat protection thermostat for you to benefit from this protection. You will also have to connect a red wire to the number 1 in the SSR, and this is what will control when the energy will be delivered or not to your heating element. So from the number 2, it will go to that connector that you disconnected from the brew thermostat, and then the energy will flow to the other end of the heating element. And I'm using the red wire because the other end is fed by the black wire. I don't want a short circuit, so to reduce these chances or to make sure that I'm not delivering the same phase and nothing will happen, I'm using a black wire, a red wire to differentiate. Okay. Also, a red wire needs to come after the power switch to the number 1 in the PID, so that it starts working when you power on your machine, and then it starts controlling your heating element, and also that it goes off when you turn your machine off. You don't want your PID working 100% of the time. Then I use the different colors to connect the number 3 and 4 in the SSR to the pins number 9 and 10 in the PID, because one is the positive, the other is the negative. The PID will control the SSR using those 2 pins. It will send the signals that will close or open the switch. Okay. And then this is another important hint for you. When you buy an SSR, it needs to be DC to control and AC to deliver the energy to your machine. And it needs to be at least 25 amps. Mine is 40, but there are some that are 16. I recommend at least 25. Finally, you will connect the thermocouple. This is a type K. It also has a positive and a negative. The negative is connected to the number 6 and the positive to the number 7 in your PID. Okay, and this way you will use the PID control only the brewing temperature. The steaming will still be controlled by the thermostat. Oh, and one thing that I forgot to mention. It is important to design the schematics or to get the schematics online of your machine, because you will make mistakes, right? So even after installing a few PIDs in some Espresso machines, when I made the first attempt in my Rancilio Silvia, I was connecting the SSR not to the brew thermostat here, but after the steam thermostat. And what happens when we do this? When we are trying to steam using the thermostat, the temperature will not reach 125 degrees, because the PID will limit it to 90, 95. I don't know how, what is the value that you set, but I was testing and I was like, okay, it will achieve 125 and will steam because I want to use the thermostat to control the steaming. But no, the temperature was being limited to 95 and it would never achieve the steaming temperature. So I need to reopen the machine to reconnect the steam thermostat and then change to the brew thermostat. So if you're more experienced, I know that we tend to think that, well, this is a piece of cake, I'm gonna disconnect this wire and reconnect here. But sometimes the wiring is confusing, the logic behind is confusing, and you think that you put the wire in the right place, but in reality you didn't. You forgot that it would limit the temperature here, or you can create a short circuit. A few friends mentioned that they activated the circuit breaker at their homes because they created somehow a short circuit when they were making the installation. So strong recommendation is to check how the wires are connected, or download the wiring diagram for your machine. Try to understand how things are connected like we did here, and then you make your installation. Okay, as from the future here, I had an issue with part of the file, but you would be lost if I didn't intervene. So here I'm going to show how you can use the PID to control both the brewing and the steaming temperature. Okay, you can disconnect the steam thermostat, and then the number 2 in the SSR shall be connected to your heating element. Another option is to use the Thermocouple type PT100, and it has a different wiring system. So 2 of the wires are the same color and shall be connected to the number 6 and 8. The other that is different is connected to the number 7. The benefit of using the PT100 is that it can be more precise if your PID allows as well. Then you can control the temperature by 0.1 Celsius degree difference. But in the cup it doesn't make any difference, okay? Another hint is that you have different enclosures for the sensors. In general, you have one that you just screw to a hole in your boiler. In the Rancilio Silvia is an M3, and in the Gaggia Classic is an M4. But I prefer one that is a hole washer type. This is the name that you will find on AliExpress. And why I like it most, because you can just place it under one of the thermostats. So you just unscrew and put the sensor under the thermostat and screw it again. It will be very well fixed, and it will have a great surface area in contact with your boiler. I also recommend using some thermal paste to improve the thermal conduction, but I don't think it's mandatory. Okay, you may test, but it's good practice, and since you're gonna open your machine, it's easier to just use some thermal paste. What if you have a Rex C100? So then the Thermocouple type K are connected to the numbers 8 and 9. The PT100 8, 9 and 10. The 2 that are the same will be connected to the 9 and 10, and the other one to the number 8. Always check the pinout because it's very confusing, and the configuration may change. There are several models of PID, and especially the Thermocouple type PT100, it's a bit confusing because, if I'm not wrong, the wires are white and only the connectors are red, and so or the wires are red and the connector is blue, and it's the opposite on the other wire. I don't remember exactly, but it is confusing, so just check and pay attention. If you have an error message, or if it's delivering a very weird temperature, you probably inverted those wires here in the PT100 or in the Type K. And if you want to install your PID before my next video, I'm gonna make a new one showing inside the Rancilio Silvia how I make the connections. Just a few reminders. I'm not gonna rate it for you, just take a print screen, and I think you're pretty good to go. But if you're unsure, wait a bit, because I'm preparing another video showing the machine inside. Okay. And if you didn't install yet, I recommend you to install the dimmer and also the pressure gauge. I'm gonna prepare another video about the pressure gauge installation, and in the future also about the Gaggia. So stay tuned. I hope it helped, but if it is still something that it's unclear, just leave your doubts in the comments and I'll try to answer to the best of my knowledge, okay? Thanks for watching and have a great day.